Alright, so here we are with question 2 of the CAPS 2018 November Matric Mathematics Paper 1. Alright, so question 2 is on sequences and series. So let me just write down the question they gave us. They gave us a quadratic sequence with 2, 3, 10 and 23. 10 and 23. Alright, so they tell us it's quadratic, and how else can we check if it's quadratic if they didn't tell us? Well, we check the differences. If it was arithmetic, these differences will all be the same, right? Difference between 2 and 3 is 1, between 3 and 10 is 7, and between 23 and 10 is 13. So we see it's not the same thing. Here we add 1 and then 7 and then 6, 13. But what about the difference between the differences? This is 6 and this is 6. So if this is equal, then we know it's quadratic. Okay, so this is quadratic. I'll ask us write down the next term of the sequence for 2.1.1. 2.1.1. The next term, okay, so we can just keep going with this pattern, right? We know this is going to be 6 again, because it's quadratic. So 13 plus 6 will be 19. So then we add 19 to 23, and we get 42. Alright, so it'll be 42 for the next term. Next question, 2.1.2. Determine the nth term of the sequence. Okay, so here we have a little trick. There's a couple of different ways we can do this. I think the most common shortcut that most people use, and which I will explain here as well, is we found a shortcut by using simultaneous equations, and we got this. We got that 2a will always equal that value. Let's first write down the general idea of the nth term of a quadratic is a n squared plus bn plus c. And we know that from graphs, right? Ax squared plus bx plus c is the quadratic graph, a parabola. So this is a parabola, but we just use n because sequence and series. And if we actually were to go plot this, we'll get something like that. Right? So it won't be continuous, it'll just be points, because we don't have any values in between these. But that's a story for another time. Right? Basic idea, it's quadratic, so it looks like a quadratic. Right now, so 2a equals that, then 3a plus b equals this term, and then a plus b plus c will always equal that term. So these are your three formulas that you can try to remember. If not, there are other ways you can also do it. I think this is the quickest and the easiest, so I'm going to use this method. So now we're going to solve. Solve for a first, so 2a equals 6. 2a equals 6, so we divide both sides by 2 and we get a equals 3. Now we can solve for b. So 3a, but we already know a is 3, plus b equals 1. So 9 plus b equals 1. So 1, if we take over the 9, 1 minus 9 is negative 8. So b is negative 8. And now we can use a and b, which we already know, to solve for c. So a plus b plus c equals 2. And we keep c on the one side, so 2, take the 8 over, becomes positive 8, so 2 plus 8 is 10, and then minus 3 gives us 7. So we have a, b, and c, and we can just write our answer then. Tn equals an squared, so 3n squared, plus bn, so minus 8n, plus c, so plus 7. So there is our general term, or the nth term. Great, 2.1.3. Now, calculate the 20th term. Okay, that's pretty nice. All we do is replace n with 20, right? T20. So term 20 will then be equal to 3 times 20 squared minus 8 times 20 plus 7. 20 squared is 400, times 3 is 1200. 8 times 20 is 160, plus 7. So that'll give us 1047. Let me just scroll down a little bit. 1047. 1047. Great. So that was a quadratic sequence. Now 2.2, we've got an arithmetic. Okay, so 2.2, arithmetic, that just means like a straight line. So again, we'll have like straight line, something that forms a straight line, these dots, but we won't be connected because it's sequence and series. But this formula will look the same, right? So a straight line used to be mx plus c, the graph. Now we have something that looks like an plus b. So we just use n instead of x's. That's the normal thing. But in general we will write down the nth term of an arithmetic will be the first term, plus n minus 1 times the thing we add each time, right? So for arithmetic, we add the same thing each time. So that was 35, the sequence is 35, 28, and 21. So what do we add here? We add negative 7. What do we add here? Negative 7. So as those two are equal, we know it's arithmetic, so we can use this formula to find the general term. What do they want? They want to calculate which term will have a value of negative 140. Okay, so let's first calculate our nth term. So we know Tn is a plus n minus 1 times d. A is our first term, so a is term 1. So Tn equals a. What is a in this case? First term is 35. So a plus n minus 1 times d. D is the thing we add each time, and that's negative 7. So we have 35, negative 7 times n is negative 7n. Negative 7 times negative 1 is plus 7. So we can just simplify that a little bit, and that gives us negative 7n plus 42. So here we have the mx plus c concept, right? Instead of n instead of x. Okay, so that is our nth term. Now we want to say for which n will this be negative 140? That's what they're asking, right? Negative 140. So we say, well, let's see. Make it negative 140 and find out. So negative 7n plus 42. Ooh, not 4n, 42. So take over the 42, so we get negative 182 equals negative 7n. And now we can divide by negative 7. So 182 divided by 7 is 26. So the 26th term will be equal to 182. And you can always just check if you're unsure. That's the nice thing about mathematics. Always just put something back to check. So if we put into our nth term the value 26, so if we work out term 26, we get negative 6 times 26 plus 42. And that'll give us negative 182 plus 42, which will give us negative 140. And that's exactly what we want to solve. Perfect. Now, question 2.3. For which values of n will the sum of the first n terms of the arithmetic sequence in question 2.2 be equal to the nth term of the quadratic sequence in question 2.1? Okay, a lot to take in there. Let's just do it step by step. Okay, so we need to find an n. That's the first thing we notice. The sum of the first n terms of the arithmetic. Okay, Sn, let's write down some rough work. What rough work we do? We'll do red for rough work. So rough work will have Sn for arithmetic. So that's question 2.2. So the Sn, we need to know that formula, right? So that's n over 2 times 2a plus n minus 1 times d. Now where this formula comes from, very interesting. It's an 8-year-old kid that calculated this or came up with this formula back in the 1700s when there were no calculators. Very impressive. And it's not hard to see how we get to that. Maybe in another video we'll do the proof of where this comes from. Okay, but that's the sum of the first n terms of an arithmetic sequence. Great. Okay, so that's rough work part 1. Sum of the first n terms of the arithmetic sequence. Okay, now be equal to the nth term of the quadratic sequence. So the nth term of the quadratic sequence, term n, the quadratic was question 2.1, and that's a n squared plus b n plus c, right, for the nth term. So we want to say, where will these two things be equal in the questions we calculated? Okay, so all we need to do is just actually set them equal to each other and solve for n. Okay, I'm going to change to blue, and now we're going to see the Sn for the arithmetic. Okay, so Sn for arithmetic, that's this equation or this formula, but with these values. We know the value of a and the value of d, right? We know a is that and d is that. Okay, so let's plug that in. So Sn equals, so n over 2 times a we said is 35, the first term, plus n minus 1, and d, the thing we add each time, is negative 7. Equals, and now the an squared plus bn plus c from the first question. So an squared plus bn plus c, so that's this equation here, or that formula. So 3n squared minus 8n plus 7. Great, so that's what we have to solve. Looks a little bit ugly, but let's get to it. Okay, first thing I want to get rid of is a fraction, so I'm going to multiply everything by 2. So multiply this side by 2, all that's left is n, and then the bracket. So in this bracket, 2 times 35 is 70, negative 7 times n is negative 7n, plus 7, so 70 plus 7 is 77, and then minus 7n. Okay, so that's on the left. On the right, we still have to multiply everything by 2, so we have 6n squared minus 16n plus 17. Okay, multiply this n in, we get 77n minus 7n squared equals 6n squared minus 16n plus 17. Okay, so we can see it's a quadratic trinomial, right? It's got n squareds, n's, and numbers. So we want to get everything to one side equals 0. So 0 equals 6n squared plus 7n squared is 13n squared. Then negative 16n minus 77n is minus 93n. And then plus 17. Yeah, plus 17. That looks right. Not 17, my bad, I made a mistake here. Hope you all saw that. So 7 times 2 is obviously not 17. What is 7 times 2? 14. Right? 14. Great. Now we need to solve this. So you're welcome to try to factorize that, but it's going to be ugly. Right? So I'm just going to use the formula here. So n equals negative b plus or minus the square root of b squared minus 4 times a times c. Okay, this all over 2 times a. Okay, let's try to simplify. Now this is mainly calculator work. I just did it on the calculator here. You can see I did some calculations here to find it out. So let's just do that. Okay, so negative 93 is positive 93 plus minus, and here if we square this we get 8649. The square root of 8649 minus 728. So 8649 minus 728 is 7921. Right, so 7921 and over 26. Okay, so n equals 93. The square root of that is 89. So plus minus 89 over 6. So n equals 93 plus 89, so 182 over 26. 26, not 6. Over 26. Or n equals 93 minus 89, so 4 over 26. So 182 divided by 26 is 7. And 4 over 26 we can simplify to 2 over 13. So one of these answers does not count. Why? Right, this one doesn't count because that's not a whole number, and we can't have the 2 over 13th term, right? 2 over 13th, that'll be somewhere between the 0th and the first term. That's less than 1, so we can't have a term that starts before the first term, right? That's impossible. Not applicable. N is 7. So what does this mean? What did the question ask? The sum of the first 7 terms of the arithmetic. Let's actually test this to just go work it out. The first 7 terms of the arithmetic. Let's write them down. So term 1, I'm going to leave out the comma points. Second term, third term, fourth term, fifth, sixth, and seventh. Okay, so if we add all of these, so if we add all of those, let's see what we get. So 35 plus 28 plus 21 plus 14 plus 7, and then minus 7 again. And let's add the plus 0 just for fun. So 98. 98. Okay, so that's the sum of the first 7 terms of our arithmetic sequence. Now let's say what is the 7th term of our quadratic sequence. And actually let's also do this by hand instead of with the formula just to see. So this is a 1, 2, 3, 4, 5th term. So we need the 6th, 7th term. Right? So here again we're going to add 6. 19 plus 6 is 25. Plus 25 plus 42. That would be 67. And then we need to add to that another 6 here. So that's another 31. So 67 plus 31 gives us 98. So 98 is the 7th term, and 98 is the sum of the first 7 terms of the other one. Will we see it works? And that's again the nice thing about math, you can always check if your answer works. Great, so that was it for question 2, which was a sequence and series question, and then I'll see you again for question 3.